Okay, today we're going to learn about arcs, and I think I'm calling this unit 7-2. Yeah. So 7-1 is 7-1 is area of a circle, which we did. Some of you did. Some of you may not have. Circumference. And one thing we didn't do, which we will do when I get back, is the area of a trapezoid. So you know the area of a circle, you know the circumference is 2 pi r. 2 pi times the radius. Area of a circle, of course, we did pi r squared. You did that for your project. And we'll do area of a trapezoid when we get back. Okay, but we're going to jump into 7-2 because it's a nice lesson for doing it when I'm away. So what we're going to learn about is arcs. So if you look here in the picture, this is an arc. It's a part of a circle, see? And what I want to make very clear is that an arc is not a segment. It doesn't have a straight line, it's not a straight line between 2 points. An arc is curvy, right? It's part of a circle. So what I did is I made you a little chart here of, right here, I did 3 things to show you the difference between what they look like, right? So this is an angle. So angle APB, angle APB is the angle in here. See it? And I color-coded that green, right? The angle, which is all in here, right? The separation between these 2 rays. Right? That's just review, of course. A line segment, which of course you know, would be, for example, AB, which I didn't draw, actually. So let's draw, I think I meant to do PB. Okay, PB. AB is a segment also, by the way, so I do show that. I just wasn't planning to, but if you connect A and B, right, like this, that's also a segment. See the difference between the purple, which is, or the highlighted, it's actually black and behind the purple. So that curve versus this segment, see? So you could have a line segment AB, so I didn't want to say that's impossible. Just wasn't part of my plan. So this segment PB is here, this blue segment, so that should have been blue, is a radius. Okay, not all segments are radius, of course, radii. And this segment AC is a diameter, right? Diameters are double the radius. They go all the way across. And that brings us to, how do I know that's a diameter, and how do I know it goes through the center of the circle? Because when a circle is named with a letter like circle P, and you'll also see this in the book, right? That means circle P also. But I usually write circle P. I don't usually use this notation, but both are correct. So we know P is the center of the circle, so that's why, because it's called circle P. Okay, when somebody writes circle P or circle O, that's the center. And we're not going to really trick you, so if it is in the center, usually we're going to tell you that it's the name of the circle. There's another quick name. I'll do much more of this when I come back, but these are called chords. So chords are segments that go from one side of the circle to the other, okay? You can have a chord like this also, which does not go through the center. Okay, that's just a limitation of my pad I'm using to write, but yeah, so I guess I'll use a straight line tool because I'm getting frustrated with that. So that's also a chord, by the way. See that black segment there? It doesn't go through the center, so it's not a diameter, but that's a chord. So chords are really any segment whose endpoints are on the circle, right? So any segment with endpoints on the circle. You don't need that for tonight's homework, but it's important to know. Okay, so segment AC is a chord. And if the chord does go through the center, then it's a diameter. Okay, now I didn't even show you what an arc is yet as far as notation, but here it is. See? Look at the difference. And I will show AB here because I did plan on doing that. Okay, so AB is a segment. I didn't draw it, but I could really quick as I did earlier, and I will. Okay, so you can see the difference. So there's segment AB. Okay, so line segment AB looks like this, and this is line segment PB, a different segment. That's a radius, actually. But arcs, as I wrote here in purple, right? Arcs have the arc symbol over the top. You can see it. It's curvy rather than straight. And if I was to do it by hand, I sometimes probably look a little different like that. Just freehand it, right? Not much difference, but that's just one with a font. Okay? So arc AB means the arc between points A and B, which is from here to here. Okay? Now, you may be wondering, which is the next slide, why would I not go the long way between A and B? In other words, why wouldn't this be arc AB from here to here? Okay? And that's because we use two letters. So let's go to the next slide and you'll see what I mean. So there's three types of arcs. There's a minor arc like we just did. That's AB, for example. Okay? Another minor arc would be BC. This is also a minor arc from there to there, and I would write that like BC. That's the name of the arc, not the measure, right? Okay, and then major arcs, just to compare them to minor arcs. Major arcs are the ones you guys were thinking about when I did that. That is an arc that's greater than 180 degrees. In other words, more than half of a circle, right? So ABD goes from A through B onto D. There's actually another name. Okay, same name. Of that arc could be called a CD. See, the center letter, this center letter here doesn't matter what it is as long as it's one of the points between A and D. Okay, notice that's a big difference from a minor arc. So another minor arc would be another, not the same minor arc, but another minor arc would be AD. See, that's from A to D, like right here. See, this arc AD. Okay, so a major arc has to have three letters, and it has to have the middle letter, it has to pass through the middle letter to get there. Okay, and they're usually, not usually, they're always more than 180 degrees. Okay, and then a semicircle is a half circle. Okay, if I erase everything here really quick, a half circle would look like this. So a semicircle, let's do semicircle ABC, would go from A through B and hit C, okay? And the measure of that arc is 180 degrees, meaning it's half of a circle. So the endpoints of the diameter always define two semicircles, see? Here's the diameter here. So there's one semicircle. The other semicircle would be ADC. ADC. You could also call it CDA. So CDA and ADC, those are both semicircles. Okay. Well, it's the same. They're the same semicircle, whereas ABC is the one on the right here. ABC. You could also call it CBA. You could also call it CBA. Okay, so the big deal here is that semicircles and major arcs have to have three letters. They have to. Otherwise, if you go the short way, you'd get a minor arc. And minor arcs only have two letters, so you know that they have to be less than 180. So you just have to memorize this. It's not too hard to do. Okay? We've been talking about the name of the arcs, but arcs also have measures, right? So I could say that the measure of arc AB is some degree, right? Which I don't necessarily know. I'm going to make it up to be 60, but I don't really know that from the diagram. Okay, but I do know that the measure of ABC, which is a semicircle, is 180. I know that's to be true. And ABD, I don't know. I'd have to make something up unless somebody gives me more information. Okay, so this would equal something. I don't know what it is. All right, so that's how this is how you name arcs, just like we name segments or angles. And this is the measure of the arc, just like we might do the measure of the angle, or even a measure of a segment, which we don't write too often that way, but we do. Okay, so last topic really is central angles, and that's what most of our homework is going to be on, is the relationship between central angles and our arcs, okay? So central angles are angles, not arcs. Let's be clear about that. Angles with a vertex at the center of the circle. So this angle here, APB, this angle APB is a central angle. So angle APB, you could also call it BPA, right? We know that, okay? Is a central angle, okay? And in this case, not always, of course, but in this case, somebody told me that this was equal to 60 degrees. That's really important. So this angle in here is 60 degrees. That was given to us. It's circle P, so we do know that this is the center here. We know that segment PB and segment AP are radii, as is PC. We know that AC is a diameter. AC is a diameter, okay? Really important. We're going to cut it into two semicircles, okay? And here it is. Here's the really important thing here. Arc measures are equal to the central angle that defines them, okay? So this purple arc is really defined by the angle. In other words, if you take the rays of the angle, here's the angle. If you take the rays, every angle is made up of two rays. Those rays kind of pierce the circle and break off this arc, okay? Another angle, let's do this angle over. So this angle over here, if you were to extend its rays, it breaks off a different arc, right? It would break off this red arc, see? Okay. So arcs are formed by their central angle. So they kind of match each other. And what's nice about it is they're equal in measure. So when somebody says here, what is the measure of arc AB? Let's just get this out of here because I can't see it. So let me just get rid of that. Yeah, so what's the measure of arc AB? So somebody says, what's the measure of arc? Notice the difference again. Arc, that's an arc, not a segment, and not an angle. What's the measure of arc AB? Well, AB, this angle here, is, arc AB, this arc measure is equal to the central angle that intercepts it, see? So if this angle is 60 degrees, very simply, this arc is 60 degrees. All right, so this would be 60 degrees. Okay, we are going to do something called arc length. I'm not going to cover it in the homework tonight, but it is something I'm going to do as soon as I get in, arc length. And arc length are different than arc measures. They do depend upon the arc measure, but they also require the radius, or really the circumference. So arc length is how long it is. So if you were to walk from A to B, how long is that? Well, that's going to depend upon the radius. A bigger radius means you're going to have to walk more. But we're not going to cover that on the homework tonight, so you don't have to really know that for homework. You just have to know what an arc measure is. So the measure tells you what, percentage of a circle, right? So 60 degrees is a sixth of a circle. So the measure of an arc just tells you what percentage out of 360, right? What part of the circle it reflects. But it's not how long it is. That's arc length, and we're going to do that tomorrow. Okay? Now, what if somebody said, and here's the big question here, what if somebody said, what is the measure of arc BC? Okay? And you're like, well, I don't know. Well, you do know, because you know that this arc, let's use a different color here, let's use red. This arc from here all the way to here, right, which includes the purple, that arc, that's a semicircle because it got cut by a diameter. It's half a circle. And you know that that is 180 degrees. All semicircles are 180 degrees. So you know that this arc has to be, this arc, that was an angle, by the way, that I just drew, but I mean this arc, this piece from here to here. You know that this arc has to have a 120 degree measure because 180 for a semicircle would be split between 60 and 120. And if the arc is 120, then the central angle is 120. And you could have figured that out because this 60 and this 120 are a linear pair. You see, so sometimes you're going to use the central angles to help you find the arc measures. Sometimes you're going to use the arc measures to find the central angles because they're always equal. And that makes life pretty easy. Okay? All right, and this is just a little bit more like an arc length just to warm you up for tomorrow, even though it's not in the homework. I just want to show you how in these circles, right, we have a right angle here. There's 90 degrees. That's a right angle. The central angle, that's this angle in here, is equal to 90. So this arc is 90 degrees. In other words, from there to there. See, that arc measure is 90 degrees. Okay? Down here in this little baby circle, it's also a 90 degree angle, and it's also 90 degrees for this arc, meaning it's a 1/4 of a circle, right? A 90 degree arc is 1/4 of 360, so it's a 1/4 of a circle. So because I'm using this small triangle versus the big one, the measure doesn't change. It's still 90. It's still a quarter of a circle. But the arc length does change. The arc length does change, okay? And I'll just show you really quick, and we'll do it again tomorrow. The arc length is just the circumference, which is 2 pi r, in this case 2 pi 10, okay, times some fraction, right? So times the fraction that the circle is. I said this was a quarter circle, right? You can see it. This arc is a quarter circle, so it's going to be 1/4 of the circumference. Circumference, remember, is the, hopefully you know this, from middle school, circumference is all the way around, how long that is. It's not 360 degrees, right? It's 20 pi, or about 60 something, right? That's the length around it. Okay, so the length around this circle, this reduces to a quarter. It's a quarter circle. It's a quarter of 40 pi, which is 10 pi, right? 1/4 of 20 pi is 10 pi, which is about, right, 31.4, about, because it's 10 times pi, right? This is pi. Okay. In this small circle down here, though, right, it's still a quarter of a circle. You see, it's still 90 over 360. This ratio is the same here. See, it's 1/4. That's a quarter of a circle. Look, from here to here is a quarter of a circle. Okay, so the length of that is a quarter of 2 pi times the radius, but the radius is different in this problem. It's 4. Okay, what's a quarter of 8 pi? Because this whole thing is 8 pi. What's a quarter of 8 pi? It's 2 pi, right? Or about 6.28, something like that, right? So you can see very different arc lengths, even though the measure of the arcs are the same. Okay, and we'll hit that again tomorrow. All right, so here's some example problems here. Given circle P, find this question mark. Now, the question mark is not very clear here, right? Be a little clearer, but the question mark is really saying what's the arc from here to here? Arc measure, arc measure. There's no way to know the arc length because you don't know the radius in this picture. It's the arc measure, okay? Well, here's the central angle of 140, so which one of these do you think is true? A little obvious, right? It's 140 because central angles, and the arcs that they intercept have the same measure, There's no diameter in this problem, so we really can't go any further. Okay, let's go to this problem. So I want you to try this. If you have a teacher showing you the video, pause the video. If you're watching it on your iPads, like tonight when you're before your homework or you're absent, pause the video and try these problems, and then I'll go over the answers. Okay, so name 2 minor arcs. Well, there's a lot of them, right? There's a lot of them. I'll pick some random ones here. So from here to here, HI. So hopefully you wrote something like HI or GH or IJ or KJ, but with 2 letters and the arc symbol, right? Right. And then I'll name another one here. I'll name GK. Okay, but all of these, there's many of them, right, etc. IJ, KJ, KI, HJ. Okay, they could also write HJ. It looks like it contains 2 smaller ones, but that's okay. That works. Okay, name 2 semicircles. Well, semicircles are half circles, and remember they require, go look in the notes, they require that you use 3 letters, right? So there's a lot of semicircles in this picture, actually. There's one here, which is probably the most obvious one, okay? But look at this. There's one here, too. See that? That's a semicircle because there's 2 diameters in this picture, see? And, of course, on the other side, so that's a semicircle from there to there. Sorry, I missed it, but you get the idea. And, of course, so is this one, which contains that green arc. There's a semicircle. Okay, so there's lots of semicircles here to choose from. So I'll write a couple G, H, J. Of course, there's other ways to write that semicircle. I'll write another one here, H, G, K. That's using the other diameter, okay? Let's do GKJ, GKJ, etc. Okay, so there's really 4 of them, and there's a lot of different ways to name them. Okay, let's name 2 major arcs. Okay, they can't be semicircles, so major arcs. So it's got to be pretty big, right? So we're going to start at G, and I'm going to go through H, which is right next to it, but I'm going to go all the way to K, right? There's a nice big major arc. So if you watch from G all the way around to K, much more than, well, I don't know about much more, but it's definitely more than 180. Okay. Another way to go is start at J, and we'll go this way. So you go more than a semicircle. So you go all the way to here, right? So that one would be called JKI, or you could call it JHI or JGI. So there's many major arcs here. I gave you 2 examples. Okay, so now the exercise is find the measures, right? So we're going to have to use that knowledge that we used earlier. Find the measure of KOJ. So angle KOJ is the angle in here. Well, that's a central angle, and central angles are equal to the measure of the arc that it intercepts. So this is a 50-degree angle. The measure of angle JOI. So that's the measure of angle JOI. So it's this angle in here, right? So let's just clear this up a little bit. Actually, I don't want to lose that. So I'll use different colors. So the angle here, this green angle, okay. Make this one green. What is the angle measure here? Well, you have to remember all of your old stuff, right? This is a diameter, which is a straight line, right? So that big angle I just outlined there equals 180 degrees. So it's really 3 linear angles, we call them, right? So 70 plus something plus 50 has to equal 180. And if you put it in your calculator, of course, you're going to get 60, right? 120, 60. So the angle in there is equal to 60, okay? Okay, now they want the arcs. Notice the difference. I'm jumping to arcs now. The measure of arc GH. So the measure of arc GH is this right here, okay? Okay, well, I don't know what it is, and I don't know what this angle is, but I do know what vertical angles are. There we go, using something from Unit 2, right? Vertical angles, when there's a big X, look like this, right? And we know that if it's 50 here, then it's 50 here. Okay, but what's that got to do with the arc? Well, the measure of the arc is equal to the measure of the central angle, so that's 50 degrees. Okay. Okay, now they want the measure of arc GIK. From G through I all the way to K, right? So it's this arc, it's this baby arc, this baby arc, this baby arc, and this baby arc, right? 4 minor arcs. And I don't know what they are. Actually, you do know what they are. This one's 70 because the central angle is 70, and this one is 60 because the central angle is 60. So what is the measure of this major arc? Well, from G through I to K is 50 plus 70 plus 60 plus 50, right? So that's I think 230 degrees. Okay, let's do one more example. Oh, actually that's it. Okay, so that should give you enough stuff to go on. So look for 7-2. It's on the drive. It's on the public drive under the new folder, Unit 7. So go to 7-2. It's a PDF. Download it, start working on it, and then finish it for homework. I'll see you guys tomorrow.